What we have is 2 points moving with uniform velocities u and v along the perpendicular axis ox and oy, and the motion is directed towards the origin. So what we have is, suppose point A moving with u towards the origin O, and point B is moving with velocity v towards the origin O. And at t equals to 0, the separation that they have between the origin is A and B. So at t equals to 0, this separation is A, and this separation is small b. Okay. Maybe I'll name these points as P and Q. That will be better. Okay. Now, if I'll ask you what exactly will be their position is going to be after certain time t. So, draw another figure for that. So after some time t, they will move some distance in their direction in which they are moving. So tell me if I'm wrong. This will be a minus ut or not. Earlier it is a, and the point p is going to move by a distance ut towards the origin, and the point q is going to move a distance which is going to be vt towards the origin. So this length is going to be v minus vt. No? Now what I want to figure out is the angular velocity of between them. So they are asking us, suppose if I have to find angular velocity of p with respect to
Sir,
q, just tell me.
sir, can you repeat again the steps, sir? A minus ut and b minus v.
So what we have is, this guy is going to be moving towards origin with uniform velocity u. So in time t, how much it will move? Ut only, no?
Yes, sir.
So this length will reduce by how much? Ut?
Yes, sir.
What it will
Sir,
become?
you are subtracting, sir. A
No,
minus ut.
correct, no, subtracting only, no? It was some distance, now you have moved, suppose 10 meters it is, and you have moved 2 meters. So how much it is going to remain now? 8 meters.
Okay, sir. Now understood, sir.
Same goes for q also, moving towards the origin with speed v. So what distance it will move towards the origin in time t vt. So what exactly this OQ length will become? Earlier it was b reduced by vt, so b minus vt. And this is a minus ut. Now tell me what next you will do after this. Any idea? I have to find angular velocity of one with respect to the other one. So suppose if I have to find angular velocity of maybe
Sir,
q
since
with
it is
respect to p.
moving like towards the like radius, so we can
No,
use
so one
centripetal
thing
act.
what we can do is, that is what we have seen in the last class, that if I give you two particles moving with some velocities, so what you do,
So
sit in
now
the
it
frame
is
of the
class or doubt, sir?
class only. I
Okay.
am discussing the homework question. So what you do is, you determine what is the relative velocity it will be having perpendicular to the line joining them, and then separation you get that, and somehow figure out the omega, which will be v perpendicular relative by r. No, that I'm not going in detail. What you will do to get that v perpendicular relative, that is something that you will do. You will be having one more component as well, v parallel relative, but that will be the one that will be changing r, so that will be our dr by dt. So that is one choice we have that we can do. Since I know the velocities that they have got in the direction this and this, so I can figure out the velocity, the relative they are going to have in the direction perpendicular to the line joining them. Correct. But that looks like a little bit hectic thing to do, no? Because what we have is, suppose if I consider at any point of time, just a moment, if I consider at any point of time, this angle is going to be phi. And those velocity, so this angle will become 90 minus phi. So if I want to determine the component of the velocity of u perpendicular to the line joining, it will come in terms of phi. And even the velocity of p perpendicular to the line joining p and q will come perpendicular to the line pq. So that velocity is going to depend upon phi only, no? So there is one way, and if you do like that, you will be able to get the answer, but I think it will become lengthy to solve. Other way is that, so what exactly the angular velocity is? So whatever angular velocity is going to be, first of all, it is defined with respect to some point, maybe a moving point, maybe a fixed point. Suppose if it is a moving point, then what we do, we sit in the frame of that point with respect to which we are supposed to calculate the angular velocity. Then with respect to us, it will become a fixed point only, no? In case if I am sitting in the frame of that point. For example, suppose if I am going to sit in the frame of P, and then I am going to observe Q. So what we will do? We are going to give relative velocity, whatever we are going to observe for Q with respect to P, and P will be given zero velocity, correct? Is it not? And then suppose I happen to see, suppose at any point of time, I have got, this is my particle Q, this is my particle P, and somehow we got whatever we wanted. But basically what we are trying to find, whatever method we are using is, so we will consider taking some reference direction. And since with respect to the point P, I am supposed to determine angular velocity, so that point P will be our reference fixed point. So at what rate this angle, the angle made by the position vector of the point Q with respect to the point P, at what rate the angle made by it with the reference direction changes, that is our angular velocity, or not? Getting the point here. So understanding this point or not? Suppose if I sit in the frame of P, I will end up seeing some velocity for Q that will be in a direction perpendicular to the line joining them. And one velocity will be observing for Q with respect to P, which will be parallel to the line joining them. And suppose at any point of time, the separation is going to be R. So one way to get omega is I will determine whatever will be that P perpendicular relative and whatever that R I have at that particular time, at that instant of time, no? Or I can figure out d theta by dt at what rate angle changing. And you know that in that V perpendicular relative term, we will be having terms containing phi. And that R, which is the separation between them, is also going to be something which will be time dependent. So there phi will be present in the V parallel relative term, which will be time dependent, and denominator also have a term R which is time dependent. So little bit lengthy it may become to solve, no? But here just I have to find rate of change of the angle. So that might be looking less, maybe less calculation involved in this, no? So maybe what I will do, I will take some reference direction. Suppose if I'll take my positive x only, my reference direction. So at any point of time, suppose the angle made by the position vector of point Q with respect to the point P makes an angle theta. So at what rate that angle changes is going to be our omega. So somehow we can do some math to figure out d theta by dt will get our omega or not. Is it not? But how to get d theta by dt? So first thought will come in your mind that somehow find theta as a function of time. Correct? Is it not? So we can find that or not? That is, but we may not find theta, but maybe sine theta, tan theta, something we can find in that triangle OPQ. So if I consider this angle to be equal to theta, then this angle phi will be pi minus theta. Is it not? So this angle phi will be pi minus theta, and in that triangle tan pi minus theta is going to be equal to OQ by OP, no? OQ by OP is our B minus VT by A minus UT. And tan pi minus theta, you know that, no? What it will be, minus of tan theta. So minus of tan theta equals to this. So tan theta will be equal to minus of this thing. So I can write down as VT minus B by A minus UT. So what we got here is tan theta, and what we want from it is d theta by dt. Then tell me what you will do. Do you think you will find theta as a function of time, or we don't need to? Anyone? You got the question. Do we need to find theta as a function of time, or without finding it out, can is it possible to determine what will be d theta by dt? Anyone? So whatever that theta is, one thing we understand, it is a function of time. Now tell me, whatever I have got in this equation in LHS side, left hand side, it is tan theta, where theta is a function of time, that if you differentiate, it will come in terms of some function of theta and multiplication of d theta by dt. Remember that chain rule in differentiation or not? And this side, if I differentiate, we can figure out whatever differentiation will come in terms of t. So left side differentiating it with respect to time will give us the term d theta by dt that we are trying to figure out. And getting the point here or not? So if I would have used this method to determine it, we will get same answer. But don't you see, without solving that, it may become more lengthy to solve. No? That is the purpose of giving this question is. So then after this, I think everyone can do the differentiation, which is not quite difficult. So what we have got here is tan theta equals to, here, tan theta equals to bt minus b divided by a minus ut. So differentiate this side. So what we will be doing is, first we will differentiate tan theta with respect to theta, and then we will differentiate theta with respect to time. And differentiation of this term is okay, no? Everyone can do that. You will be applying the quotient rule here. Is it not? So this will give us secant square theta into omega. That is what we wanted to find. And differentiation of this one, denominator we square it up, it will become a minus ut square. Then we get v into a minus ut minus of plus than u vt minus b. Check the calculation, anything wrong, you tell me then. And secant square theta, we can figure out secant square theta at a given time. So secant square theta we know as a function of time, and every other thing is in terms of t. So we can find omega as a function of time or not. See, calculation is reduced drastically if I try doing by this way now. Or not, tell me. So what we get is, so simplify this thing everyone. Omega into secant square theta equals, so AV, so simplify this thing everyone. It will become AV minus BU, I think so, by A minus UT square. And secant square theta we can find, but we know it is also equal to 1 plus tan square theta, and tan theta we know already. So I'll write it down like that. So omega into 1 plus tan square theta, and tan square theta is Vt minus B by A minus Ut square equals to AB minus BU by A minus Ut whole square. So simplifying it, omega will come out to be AB minus BU by A minus Ut square plus Vt minus B square. So something different here we had than the regular way. That's why I gave you this question. All of you understood or not? Any doubt here? Copy this thing everyone. After copying, tell me. Second part is easy only. That is so that it is greatest, or that is basically find the time when omega will be maximum. So there is more of a maxima minima question, not like is a physics question. Since I gave you what omega is a function of time, somehow you may figure out the maxima minima of this thing. And what exactly you will do to figure out the maximum value of omega, or when omega gets to become maximum. So what we have got here is, this is the omega that we have got. And whenever you come across some function like this, same approach you can have. See, whatever you see that we have got in numerator is constant, and denominator is only which is variable. So whenever this denominator will become minimum, then we are going to see omega to become maximum. So instead of finding out the maximum minima of omega, we will find out the maximum minima of whatever we see in the denominator. And you get that way, no? Differentiation will be easier to do for the things that I have in denominator. Otherwise, I will have to apply quotient rule or whatever, will become a little bit lengthy to do. So what I'll do, that function, whatever I have, it is a function of time, which is our a minus ut square plus vt minus b square, and we'll differentiate it. df by dt will be equal to minus of 2u a minus ut minus of 2b vt minus b equals to 0. So simplify this thing and you will find that at t equals to, so what we see here is they're asking us find maxima, okay. And also I see only one point where my differentiation is becoming 0. So I don't need to check for the second condition. No? Straight away we can tell it will be a point of maxima. Why? They are asking us maxima. And there's only one point where differentiation comes 0. So there's no confusion that it will be maxima. If you want, you can check double differentiation, but you don't need to. It will be 2 I can take out common. We have minus of au plus u square t plus of, just a moment, this v here, my mistake, this v here. So next it will be minus of sequence minus of plus of vb and minus of v square t equals to 0. Simplifying it, you will be getting whatever it is they're asking us to prove. No? Is it coming same or not? So here plus will come. So correct it here. So t will be equal to our au plus vb by u square plus v square. And even you can find double differentiation, and you will see the double differentiation of this function will come negative. You can see that, no? Will come negative. Understood now?
Yes, sir.
Okay. Check out this question. So what we have is, a balloon starts rising from the Earth's surface. The ascension rate is constant and equal to v naught. Due to the wind, the balloon gathers the horizontal velocity component Vx equals to ky, where k is a constant and y is the height of the ascent. Find the dependence of the following quantity on y. The horizontal drift means how much it has traveled in the x direction. The total tangential acceleration of the balloon, the normal acceleration. So normal acceleration is the one that is perpendicular to the velocity vector. So it is another name for the radial acceleration only. Okay, so I hope you got the question. So somehow the balloon is rising up with constant velocity. Don't worry about that how. There will be some force apart from gravity acting on it that may make it to have motion with constant velocity. No? So there will be a buoyant force because that balloon will be filled with something lighter than the air. That buoyant force will balance the force of gravity, and somehow it is able to move upward with velocity v naught. So it is kinematics question, so we don't have to worry about the forces here, just we have to solve for whatever they're asking us. So do you want to try? Just let me see the time. Okay, I'll give you 2 minutes to think what you will do, then I will solve it. This 45 minutes, 40 minutes extra classes, looks like it is very less, but this extra little bit also is going to give you huge impact in the end because I'm saving so much time. And really, if you ask me, it is not possible to complete syllabus properly in the time that is allotted for weekend. Okay. I will have to cut down on some content, or then only I can do that. So that I don't want to do. It's not like I want to, I cannot. Any idea what you will do? So the
Sir,
speed
here the acceleration is uniform, sir.
that you have to decide on your own, no? And how come it will be uniform? It is obviously not moving along a straight line path. So even if speed was constant, which is not, because y changes, so vx changes, vy constant, okay, but vx not constant. No? The
Sir,
speed not constant, even if it was, since not moving along a straight line path, so it will have some acceleration. So correct, no?
sir, so we can't use the kinematics equation here, sir.
Kinematics equations only we will use. What else we will do? They have told us
Sir, but
something, no? So
we
try.
can use the kinematic equation when the acceleration is uniform, na, sir.
Dude, when we find things through calculus, that is not kinematics. In school, they have thought that is kinematics. When A is constant, kinematics, A variable, not kinematics. Then I told anything like that. Forget about school stuff when you come here, okay? Now?
Okay, sir.
A not constant, then we solve through calculus. That is also kinematics. Kinematics means we don't care about the reason behind the motion or the forces causing it. Just we care about the description of the motion, no? What force is making it to have that acceleration, we are not getting into that. Just we want to know what acceleration it has got so that I can find velocity, position and things like that. So the things you need to know what data given in the question and how come I can utilize it to figure out the things that they are asking us. So what they have given us, it is rising up with constant velocity. So didn't they have given us the velocity in the y direction and the rate of change of y in the y direction, no? Rate of change of displacement they have given in the y direction or not? And Vx depends upon y, and y we can find, so Vx we can find or not? Understanding it. So you first decide what I have to find, speed. To find speed, what I can do here, I can find x component, y component, then I can find speed. Is it not? But how to find speed in y direction? Given v naught. How to find speed in the x direction? Ky, but y not known. So somehow I have to find y. And who will tell me what y will be at any point of time? This whatever motion it is having in the y direction will tell us. So look for what kind of motion it has got in y direction. That velocity constant. So dy by dt v naught. So we can find y or not. Once we can find y, we'll know vx. Vx we know, vy we know. We can find speed. And once we can find speed as a function of time, we can find at what rate that speed is changing. Is it not? So maybe I'll solve it now. So what it is given is, understood, no? Overall what we have to do. So what is given is the velocity in the y direction is v naught. So what it is basically, the rate of change of y is the velocity in the y direction, that is v naught. So dy I can write down as v naught into dt. So if I write down dy equals to v naught into dt, what you will read it, or what exactly it means. It means dy is the change in the y when in the time interval dt, which is very small. Correct. Now I need to know whatever y I am going to have at the position. So what I must do, I will be integrating it only, and since what they are telling us, it is rising from the Earth's surface. And if I consider the Earth's surface to be our zero height, it means that t equals to 0, y is 0, and at t equals to t, y is y. V naught constant, we can take it outside the integral. Y will become equal to v naught into t. Simple or not? Simple, no? All of you got it till here? Now you might have got the idea what is to be done next.
Sir, this is for the y direction, sir.
Yeah.
Okay, sir.
Now they have told us what is the velocity we are going to have in the x direction. Vx is ky, y we know. So what it will become? K v naught into t. So the velocity of the particle, I can write it down as Vx I cap, Vy j cap. So what we have got is the speed will be root over Vx square plus Vy square. But before that, they are asking us the horizontal drift as a function of y. So we can figure it out. So what we can do is, since they are asking us what is going to be the displacement it will have or how much it will travel in the x direction, considering that starting point is our x equals to 0, so dx by dt is given to us. No? Dx by dt is our ky, and they are asking us the drift it will have in terms of y, not in terms of t. So what we can do is, since I know what is going to be our y in terms of t, I will figure out x in terms of t, and then I can replace t in terms of y. There is one thing we can do or not. So what we have is t equals to, so from this equation you can see that t equals to, or y equals to v naught t. So what we get is k v naught t. Then it is easy only, dx will become k v naught t dt. Integrate both the sides. At t equals to 0, x 0. At t equals to t, the x is x. So we get a v naught into t square by 2. And then what we have got is t equals to y by v naught. So just I'll replace t there to know x in terms of y. So since they're asking us like that, a v naught by 2 into y square by v naught square. So we get x as a function of y as a y square by 2v naught. Easy or not? First part. Next part, they're asking us the tangential acceleration, means rate of change of speed. So how speed is changing, we must find what speed is as a function of time first, and that we can do it easily because I know what velocity it has got in y and x direction. So speed is going to be root over vx square plus vy square. So it's going to be equal to Vx is k v naught t, so k square v naught square t square plus v naught square root over, no? So this is our speed, and the tangential acceleration, you know, it is rate of change of speed, and I think everyone can do this differentiation using chain rule, no? So whatever we have inside root, we differentiate that thing with respect to that, and then we differentiate, sorry, whatever you have, you differentiate it with respect to whatever I have inside the root. For example, if I had this to be equal to some f of t, so what you will do? You will differentiate this root of f of t with respect to f of t, and then you will differentiate f of t with respect to t. There is something I don't think anyone will have any trouble with, but still I'm telling you. So differentiate it, and that will give you whatever is going to be our speed as a rate of change of speed. And if it comes negative, means speed is decreasing. If it comes positive, means speed is increasing. So dv by dt will become, so differentiating root x with respect to x will give us 1 by 2, 1 by 2 root x. So it will become 1 by 2 k square v naught square t square plus v naught square. And then differentiating whatever I have inside the root, that is easy only. It will give you 2k square v naught into t. So what we have got, at to be equal to k square v naught into t divided by v naught square, or maybe I'll take out common v naught square and I'll take it outside the root just to simplify it. So it will become, and 2 cancelled only. And if I do that, it will cancel out the v naught I have got in numerator. So check out, it will become k square t divided by root over 1 plus k square t square. All of you got it now? And in case if you would like to find our AT in terms of y only, okay, they are asking us dependence on y only. So we can do that since we know that t equals to y by v naught. So I will replace wherever I see t with v naught, and we can figure out AT in terms of v naught. So it's going to become just a moment. A square y by v naught square plus k square y square. Check that correct now. I have written after simplifying it in my head. Wait, I did a mistake here. V naught square here I have. So one V naught will get cancelled, one V naught will remain. So just a little bit change here. It will be k square y by 1 plus k square y square by V naught square. So even I can write it down as k square y V naught by V naught square plus k square y square. That will be our tangential acceleration in terms of y. Next, they are asking us to determine the normal acceleration. So what to do to determine the normal acceleration? Any idea? So you may try to think in the way we have seen in the class, that maybe we will find radius of the curvature and speed we know, so v square by r will be our radial acceleration or normal acceleration. But how to find r? Because to
Sir,
know r,
using the formula 1 plus dy by dx.
but that formula when useful? When I know function, no?
Yes, sir.
I don't know the path along which it is moving. So either somehow you determine what path it is along which it is moving, or else we may do something else also. Both the ways answer will come same. We will try both the ways. But maybe you don't try by finding out radius of the curvature. Maybe look for something else. So what else you can do? Any idea? And that you know already. It's not like something new it is. See, in projectile, we discussed that thing in class or not. While in the ascent, during the ascent of a projectile, before it reaches the
Yes, sir.
maximum
Due
height,
to
the speed
acceleration,
decreases. And there we took the correct no? So I took the component of the g in the tangential direction and in the radial direction to figure out what will be the tangential and radial acceleration it will have. But what was the net acceleration is g only. So if I will give you this is the net acceleration a, and if I give you this is the tangential acceleration, don't you think given total acceleration, given just a moment, I have to take this call. So what I have is the acceleration in the x direction, y direction 0, acceleration in the x direction dvx by dt, and that will be dy by dt of ky. K constant will come out, so k into dy by dt. And what is dy by dt? That is v naught only, so k v naught. So ax we know, ay we know. So what is the net acceleration? We don't have anything along y, so net acceleration is just along x, which is k v naught. And once I got net acceleration, that will be root over ar square plus at square. So what exactly ar will be? It's going to be root over a net square minus at square. At we know, ar we know. So we can at we know and a net we know. We can figure out ar. All of you understood? No, easy or not? Maybe at first glance looked difficult, but easy or not? All of you understood? No? So basically, we have discussed two questions only, but it matters actually. Today's date is 7 p.m. and another class at 7:15. So I'll end the class now. Okay, those who have copied can leave the class. Any doubts, you ask me now.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.
Okay.
Thank you, sir.
Bye.
Thank you, sir.